arrangement and selections with repetitions for objects. So here, note that we consider that set containing 3 elements, and we come up with comparison for arranging that set, provided that if there is a repetition or there's no repetition allowed. Okay, this happens when there's no repetition again, and this when there is repetition. So, and we've come up to the idea if that will be always true. Yes, that's true. So we will be showing you this theorem. Okay, so I've shown you the theorem already, and I've shown you the outline of the proof. Actually, it's not technically the outline, you just can come up with some additional words, and that's the entire proof already. I'm just showing you that step-by-step details in order for us to understand how the proof goes. Okay, so we're done with that example. There's a 4-story house, and we have to paint the house, each story out from 6 different colors. And here, so I have here the illustration now. So find the number of permutations of the 5 letters. We have A, B, C. Okay. So observe that the repetition happens on the content of the set, or the elements of the set. So if you notice, so note that you have A, B, C. Now, our goal is to find the number of permutations happen on these elements. I think it would be better if we have to write this in this way rather than that. But anyway, our purpose is the question to answer the permutations out of that 5 letters. So observe that these 5 letters can be written like this, diba? Assuming that those letters are distinct. However, this is obviously the same. These letters are obviously the same. So, di ba tulo din sila? Okay. So,
by factorial they are distinct.
yes. So, suppose that we have this, suppose we have x be the number of desired permutation. Okay? So you have the x be the number of desired permutation. And if we fix this, kani siyang tulo, let's imagine this as just one element. So if we fix this, say, suppose for example, mag-select ko ani. I have this. Na. Hindi na lang ako understood niya muna yung arrangement. Okay. So, kali siya, pwede na ko rin siya suppose ako rin siya i-label as A sub 1, A sub 2, A sub 3. So, I can write this as well as B, A sub 1, A sub 3, A sub 2, and C. Tama? And so on. So you can permute these 3 letters. Now observe that the arrangement of these 5 letters is 5 factorial. And the arrangement of these three letters is 3 factorial. Okay? So therefore, you can write this x, you can express x as what? 5 factorial over 3 factorial. And this is ilan man 3 factorial times 4 times 5 over 3 factorial, and you get 20. So there are 20 desired permutations.
Consistent. You also give the arrangement for the B and the C.
Sir?
If you assume that the A's are now distinct, so ang arrangement nila 3 factorial, di ba? Ipunta na lang kung si B, kung si C. 1 factorial. Not 1 factorial.
Oh yeah, you can write this as 1 factorial,
1 factorial.
and 1 factorial. So nakay 1 factorial, nakay 1 factorial. So you still get, but 1 naman siya, 1, and you'll get 3 here.
Ay lang i-cancel. Butang na na.
Okay, sorry.
Butang na sa post.
Dili na lang. 1 factorial, 1 factorial.
May lang yan.
Nakuha? Okay na? So, now from that illustration, we will come up with a result. Okay. If you notice, this kind of formula here corresponds to this. Diba? Natawa. This is a specific R, and I'm going to report it last time. Diba? However, it's just introductory. I think I remember when Sir asked me this kind of permutation. Like, you have, suppose this is the R sub 1, this is the R sub 2, and this is the R sub 3, out from the entire set. Kung ano rin? Murag example ni mo.
Itong example is lang itong plate. Itong shooting.
Hindi ko ka-remember. Basta I think, yeah.
Problem number 48.
Yes. Oh.
Check this ka to.
Okay.
Yes. So this is the answer of your problem here. So you have to consider a collection of R objects. So again, di ba, previously I have explained to you how to arrange objects in a given set at a given time. At a given time R. Here, suppose you have a collection of time. So you'll get this. So you have a collection of R objects in which R1 are of type 1, R2 are of type 2, and so on. So where, of course, the summations of all those times is R. So the number of different permutations of the collections of objects, this is your symbol, this will be the formula. Okay? That's the proof. Okay. Sige daw, ano na i-try? Sige, outline lang. First idea. Again, take note that the sum of all your R sub i's is R. Okay? So, and remember, R should always be less than 4, less than or equal to your N. Okay, so, sama ni. Suppose you have R sub I here. So when R sub I, you have R sub I positions, di ba? Okay, so you have R sub I positions at a given with what's the corresponding R sub I? Pero consider a collection of R objects in which R sub 1 are of type 1. So here, R sub I of type I.
Mag-iwan ka.
Okay. Sige sir. Wait. What is for I?
For easy proving, no? Parang litan ang n na to 2. Wala. Wala po.
Yes. So, biasa na to ka n siya. So, atong I dili kay mo range siya to n. So, let's try this one. Let's have to be specific. R sub 1 positions at a given type 1. Tama? Okay. Another R sub 2 positions at a given type 2. Nakuha na? Okay, so next is si R sub 1, nakuha na to siya coming from atong number of R, tama? Diba, ang atong R is equal to the summation of R sub I from 1 to n, tama? Pero, the summation of your R sub i's from 1 to n is R. So if I pick R sub 1 here, you have R choices from R sub 1. To pick R sub 1. If you pick R sub 2, you're done with R sub 1, you're left with R sub 1. So you have R. If I pick R sub 2, you'll get naman sa book ata. If you pick R sub 2, naapay nabilin nga R minus R sub 1 position. Tama? Okay. So pasabot nga if I pick, this is R. If I pick R sub 1, napay R sub 1 in here. Now, nakuha na ako sa R sub 1. Now, out from R sub 1, if I pick R sub 2, dili na siya R, di ba? Nakuha na ako ni R sub 1, so you have R sub 1. Ana?
R minus R sub 1.
And so on, until pila na yung mamili na kay R minus R sub 1 minus R sub 2. Ako lang yung class, i-add na lang ako. Plus, ko to.
N minus 1.
Ha?
Minus
What's n minus n? R sub n minus 1. R sub n minus 1. So naakay, sama ni siya nili?
R sub n minus
R sub n.
Walang friend.
Sorry. Okay. Nakuha na. Every one. So that's a combination, di ba? So
the procedure is telescoping. Para makita na ito ang compute tama sa actual trivial ito para makita na.
ano sir?
It is done by telescoping mo na.
Expand.
Expand lang ato ang 3 tabi para makita.
Sige ha.
Ito sa left side. So cos R is equal to R1 plus R2 plus R3 na na. So that you will have the idea of how the telescoping was done. Have you done telescoping in sa surface at sa sequences? Series?
Math 71.
At 71.
So you have R, nakay piling R sub 1. Nakay R, di ba kung alam R sub 1 sa R, minus R sub 1, nakadelay R sub 2. So kung R sub 3 na delay, kani siya mo minus ay sila. So you have R minus kani. Tama?
Simplify daw lang.
And so on.
Di alam tama.
Sige, dirita.
Para makita na ito. Equal to...
So kung sa siya, this is R factorial over R sub 1 factorial times R minus R sub 1 factorial. Tama? Okay, this is kani. This is R minus R sub 1 factorial over R sub 2 factorial, and you'll have R minus.
Kasi dapat ipakita niyo mo, sa kung ipakita niya,
That should be R factorial.
R factorial, R1 factorial, R2 factorial. Ay,
Multiplications, sir.
product name?
R2 times R3.
Sige daw.
Okay. Okay, let's see. So you have so many. R2, R sub 1 minus si R2, tama? So you have R2 factorial. I can write this kanina. Diretsoan ako ha.
As R minus R.
Diretsoan ako.
R minus R.
Okay ha? How about this? You get R minus R1 plus R2 factorial. R3 factorial. You'll have R minus R1 plus R2 minus pa yun. Minus R3 factorial. And sa man siya, I can write this as ako siya isulod ma-plus ni kailangan may minus din tama. So, this is equal to R minus R1 plus R2 plus R3, tama? Tama po? Let's check. Tama po? Naroon po ang factorial din. So, wala yung
Si negative R3 ang student.
oh yeah, ay ganun ko eh. So, na to siya, negative, positive na siya. Okay na? Sila talaga din, may factorial na rin. Okay. So, sa mani, cancel. Basta pa.
So,
Look at R factorial. For R1, R2, R3. R1, R2, R3. Ano din siya? Ano ni? Nice sipya. Walang sipya.
sa book, can you
Sipya siya. I can't.
Tapos final kinawala ko.
Ganito na. Ano sipya?
That's correct. Pero
Sakto mo, R1 plus R2 plus R3 kay Coleman dyan yung R. So, zero na siya.
na siya.
Ah, yeah. Oh, sorry. So, R minus siya to, di ba? So, you have R 0. So, you get 1. 0 factorial na siya. So, you get R. Thank you. R1. R2. R3. Okay.
Nang basa mo, ayaw na i-attempt ng mag-ambition mo at the end. At sa mo sa pagkakita mo kung trade.
Ginagmay.
Ginagmay lang. Diba? Ano ba ito, itulyugan kung hindi mo lang sa dahon. Diba?
Kabayan daw ka.
Kansig ka.
Mabayan bayad sa
Hinahin sa agyo,
Paulan
hinahin.
nila, itong mga bulbul, itong mga puto, diba? Tanawag mong tiyan.
Sama na, ito bali i-show up.
Hindi na.
Wala na.
Ano na sila?
Okay na.
Imunan ninyo yung technique na yung specific tablet lang para mamanage ninyo. Yung sa itong nahapon siguro, we are the most abusive people in the world, mathematicians, and we are the most people who can really imagine quantitative. Sa may sumunod mo na.
Okay, so we're done with permutations at a indefinite number of times. So now let's
Indefinite or unlimited.
okay, so now we have to
Limited.
consider this a multiset. Okay, this has something to do with what we're done previously, but let's it's such that we're focusing on the let me correct myself. Ingon ko kanina indefinite. No, it's definite number of times. Here we're talking about the indefinite number of times. Okay, so why is that? So let's check on this definition first. We have a multiset. So this is a collection of objects, but its members need not be distinct. Okay, so you have a collection of objects, the members are not distinct. So same with kanilang. pareha ana. But the difference is that we're talking now of the indefinite word, the word indefinite. Okay, although walang isulti sa book na indefinite, I'm just using the word indefinite in layman's term. Kaya siya,
Unlimited, you know.
unlimited, yes.
Unlimited. Your cellphone, no? Unlimited.
Expired.
Pero mas tayo, unlimited.
We expired the house. Okay, so here, so let's have an illustration. Kani.
Okay, so,
So given M, okay, then your M is a multiset. So katotong ibuhat din na is a multiset. So it consider the definite and the indefinite. Pero ganina atong i-focus lang is definite. Here, what if kahit na siya? The generalized na siya. So we have to consider this set here, M, which is a multiset consisting of you have 3 A's, you have element 2 B's and 1 C. Now we can also write M in that way. Okay, di ba kami naman dili siya necessarily na distinct. So instead of writing to look at A, you just have 3 times A and so on. Okay. Now, so in general, if I generalize these, kanya akong labas. Okay. You have R1, which corresponds to the first object, which is A sub 1. So example, this is 3A, you have 2B, and 1C. So on. So, muna siya ang generalization of a multiset. So, observe that your N, so the number of objects are still distinct, so that means it's a finite set. Your N is an integer as well as with the R1 and up to Rn. Okay. Wala na yung question. So, consider this remark. For each I, from 1 to n, the number R sub I is called the repetition number of the object, AI. So, kani siya, R1 is the repetition number of object for A1, and so R2 with the A2, siya ang repetition number of objects. It tells how many AIs are in the set. And for convenience, kani siya, given object A, we may write the infinity times A to indicate that A can be repeated infinite number of times. Okay, so ganina, di ba? The n is an integer, so that means we're talking of this as finite. Ang pasabot pagkudanan niya is, you have a set which is infinite, daghan, infinite siya. You have to regroup them na may gabalik-balik ko na to. It's infinite, technically, assuming that those elements are distinct. However, na may gabalik-balik ato. So if you regroup them, mahimo na siyang finite. Muna yung kasabot nila. Okay. So example, kada siya. You have 2 times A, infinity times B, which is technically, hindi ko na po siya yung anaon, pero okay, just the infinity that represents the infinite number of times ang B. Okay, don't be confused. Anyway, we know already that that's not possible. So kani siya, ang ato lang is just to represent para ma-find na itong set ng tawag. Although that technically the original thing is that it's infinite set. Ako ha? Okay. So consider this remark again. So an R permutation of M is an arrangement of R objects taken from M with at most R sub I of AI. So ani, you have your I ranging from 1 to n na finite na siya, taking from the original infinite set. Okay, so an R permutation of a multiset siya is similarly defined, except that AI's chosen is not limited for all I.
Sunod na ang imungan ay dapat infinity yan.
Kung nasa sir?
Anong imong karuan?
Yeah, infinity siya ha.
Ano ba yan?
Sir.
Ano yan?
Sir. Yeah, infinity siya. Bigupia naman. Oh, bigupia naman. Ano to Kevin? Okay.
So, kada yung mga example sa taas na yan, wala ka na, pero example naman ano.
Yes.
So, excited ako ito.
Typical.
Limited.
So, okay na ng illustration pa. Okay, let's consider this theorem. So, you have given set A, kani siya. By the way, kani siya ka theorem ha. Let's consider this as an exercise as well because it's just a parang mirror siya sa previous theorem na to. Lataw natin nga, ako i-show ang mga theorem. Okay. If you notice, ito rin siya ang first theorem. Kana siya. Diba?
Katong
First theorem. The second theorem, more po na siya.
Asa din na siya stage siya balik sa book.
Kuhaan siya. Generalization na siya. Diba? Nag-start na from a very small one, infinite set na. Suppose we are given in, finite set na tatong starting. Suppose we're given an infinite set. So infinite set, you have to rearrange them, group them, in order for us to create a finite set. Diba? Atong ganina. You have, kanisiya, you have a set which is infinite, 1 million bakabog na dira na A, and we cannot count the B, and so on. Hindi mo nila nakuha na. Although this is technically wrong to represent it, ano na siya? Just a representation na ang A is written infinite number of times, and so on with the other elements. So kanisiya is just a mirror of the previous theorem. Nga, this theorem daw also holds even if you are given an infinite set.
Nabasa man ninyo na sa page, 24 so, 34 subos. Diba? The results were to adjust ang phrase na ito kanina ay yung isulti ko. Mas general din siya.
Mas general siya.
Provided that i-regroups
Yes, you have to regroup them. Kaya infinite man siya, di mo na mo makita.
then apply the previous.
Yes.
By the way, do not use that notation in the ordinary
Yes.
discussion of ano because infinity times and number is not defined.
It's not defined.
Kanina tahon na ito na, di ba? Wala na may determination. Wala na siya, wala lang notation for convenience na. Di ba?
Ang i-emphasize kanina na, although this is wrong to say na infinity times a number, dila lang is representation na.
So we are abusing, no? Abusing notation.
Okay. I use the word exercise because it's just a matter of what we have proven already. First theorem, second theorem. That is why ako siya niligilan ng 1M. That means theorem 1, multi-set version. And so on.
Discuss the example.
Okay. So this is an example. So find the number of ternary sequence of length 10 having 2 zeros, 3 ones, and 5 twos.
Can you give one example before you attempt to solve the problem?
Okay, Alice.
Bilang sila na ganito, 2,520. Kung sa susunod mo na, give example.
So ano natin na? So ato rin siya i-write. I-write sila ito para makuha na mga tools.
Kung ano ang example sa para masaktan, ternary gani, string of 3. Length 10 at string of 3. Gamito ng 0, 1, 2. Diba? Ternary man. Kung binary, 0, 1.
0, 1.
So gamito ng 0, 1, 2. Pero length 10 man eh. Ibigay example, length 10, 2, 0, 3, 1, 5 2s. At ang example yan
2, 0, ano siya?
Okay.
Pwede ni
1 zeros, 3 ones.
2, 0, 3, 1. Pinani?
Upat ka to. 5.
4, 6, 8, 10.
Isa number 1, no? Isa na siya.
So, ako siya i-rearrange. You have 1.
Itapad ka na. 0, 0, 0, 0, 0, 1, 1, 1, 2, 2, 2.
So, ilan na yung mga computer? 2 na. So, Wala pa rin 2,580.
Okay.
Huwag daw.
Okay, so saan naman din siya?
Okay, sample.
Di ba, you can have a pila ni set? 10 kabuok.
Yeah, you
So,
must-
sa ganito siya na kay, you can write them as 10 factorial, assuming that they're all distinct. So, you have 10 factorial. But since repetition happens here, at the previous na example, now you have two zeros, so na kay r sub 1, r sub 2, r sub 3.
Okay. Ang tungkol design ni mo.
So, atong multiset ani, na kay,
M, okay, M as in mark ones.
so, na kay,
Zero.
ako anak na ang bili mo kuan nga, this is the 0, this is the kuan. You have, pinamit 3, then you have 5.
So, question. Sa kayo mo ka? Sa iyo nga?
10.
Ha?
R sub 1 is 2, R sub 3 is 3,
So r sub 1 plus r sub 2 plus r sub 3, pila man?
Okay, 10.
10.
So, yung 10 na, no?
So your r sub 1 pila? 2.
Pila yung last one? 2.
2.
So you'll get 2 factorial, pila? 3 factorial.
3 factorial.
And then
5.
factorial. Okay, so ano siya? And that's the answer.
2,500.
2,520. So kamo na compute ha? Okay na? Okay, so next.
You discuss the ano, ayaw sa na, atong I'm interested with 1.6.6.
1.6. Kasi 1.6.
So, no, show that all L factorial is multiple.
Oh, yes sir.
Ako lang sa, hindi ako lang.
Okay, sige, sure.
Because that's very interesting. Ayaw sa na, halika lang na. Okay, that's nice. I'm sure that L for L factorial is multiple of 2 to the 3 and 3 to the 4 is natural number L. What comes immediately to your mind if you're given this problem is to use
PMI.
PMI, pero it's difficult to use PMI. Have you tried?
Gitry na ko PMI.
Mabugang niyo mo? Sige daw, electricity PMI. Very good.
Char.
May PMI.
Pero nandiyan na ang copy. Ano, try na to. Sige, so ito, you have, mention na pa itong N ha. So suppose, saan na akong gamit? K,
PMI na kasi, kompleto mo, 3, 4, 5, 6, 7.
I,
PMI. Principle of work and Irene. Sige daw. Let P and B for N factorial is a multiple.
B,
Iyan na ng data.
is a multiple of 2 to the 3n times 3 to the n for each number n. So
P1.
let's show P1. So if this is P1,
4 times
4 times 1 factorial, you get 4 factorial divided bilang 4 factorial 24. Okay, so 24 and you have 2 to the 3 times 3 equals 8 times 3 you get 24.
Okay, so 24. What?
So
Tama na? O, P2 lang ta. Sige.
so kung dito ni siya, you'll get 4, 2,
O, yan.
you'll have 8 factorial. Back, saan yung calculate?
Sige lang, ito na lang 8 times 1. Ayaw to.
So you'll have
8 times 7. Ano na?
7 times 6 times 5 times 4 factorial.
Ito naman ni calculate. May expansion mo.
So this is 2,
O, the
6
6
times 3, 2. So naakay this 24 times times 24 times 2 to the 3, nakay 2 to the 3 times 3, pag yun. So this is 24 times 24. And remember, this is 48, which is a multiple of 24. This is 24, so therefore it's true. Okay?
Assume.
So,
PK.
assume that
PK is true. Assume that PK is true.
that is okay.
Pasabot ganyan ang multiple to.
So if that's a multiple of a number, then that number, I mean, if A is a multiple of, sorry, if 4k factorial is a multiple of 2 times of that one, then there exists an integer such that you can multiply the integer by this to get the 4k factorial. Tama?
So, kaning nasa right, divide siya pa 4k factorial.
Teacher.
There exists an integer.
Yeah, that is.
Kaya mo multiply ani
Equals at
Wait, ano mo? Ikot na dali, divide. Or, ang meaning nga ni 4k factorial over kana is equal to the
integer.
So that,
So, kaning nasa right, sir, divide siya pa 4k.
yes, ang meaning is saying 4k factorial divided by 2 to the 3k times 3 is equal to C or something. Teacher. Good. Una assumption, no? Show.
So our goal gani siya.
4k plus 1.
Ako sa i-translate ni sir ha.
Ito yung ngayon na. C times.
So that 4 to the x.
So naatay atong goal is
Show.
4k
Oh, parenthesis na.
4k plus 1 factorial
4k factorial.
is equal to
2 to the 3k plus 1.
2 to the 3k
Oh,
plus
patay.
1
Parenthesis.
times 3
K plus
k
1
plus 1
times
times
Q. Multiply.
yun na
Q
naman
na. Or sa Q. Teacher.
or sum q.
Teacher.
Okay.
Sige na.
So 4k
Sige, expand.
you have 4k
Plus 1. Ay, distribute
plus
mo?
4. No. Sorry po. This is 4k
Plus 1
plus 1
times.
times 4k factorial.
Very good.
4k factorial is equal to that. So you have 4k plus 1 times 2 to the
Okay.
3k times 3 to the k times t. Ang atong akong ko 3k t. Excuse me. Wait lang.
Kita ng for. Live sa ano? Dito. Live na to na. Sige, tutubig ko.
Story na yun.
k plus 1. 2 to the 2, mahimo ni siya 2 to the 3k plus 2
Plus 2.
times 3 to the k. No, actually sir, let's solve kung separate claim. Nagigamit na ko siya din.
Para sa
Nakalimut. This is 3k times t. Kulang pa.
3k plus 3.
This is integer.
Sige, makita rin yung dyan yung plano. Sige, nasa gamer.
Ako siya try distribute ako eh. 2 to the 3k. Ay, hindi mo siya gamit.
Kaning kuwan. Kaning k plus 1 of the integer naman na, no?
Oo.
Pero ang problema nimo kaning
So ako siyang i-paddle eh.
ayun sa kasi ito na.
Kani siya,
Wala
kulang pa
lang yung
ni.
bukagan. So, monit, Q ba ne?
Ako, kanang kulang pa ni siya o 2 times 3. Kulang 6.
Diba? Wala no?
I-divide natin 6. Kung ito kasi siya Q. So, kung Q na siya, ano, Q times. So, akong goal is 2k plus 1 t is equal to
3k plus
Q
3.
times 2 times 2 times 3.
Wala pa
This
nag-6.
is integer. This is integer. This is integer. K plus 1 times p 2 to the 3. So this is kani siya is an element of derivation. Sir,
Plus 4. Ano, may sunod, minus 1 pa?
Kana ba sa first line mo mark bitaw?
Ah.
4 times k plus 1, di ba i-distribute natin ang 4k plus 4. So when you subtract, so it should be 4k plus
4
3.
times 4 pa man ko?
So it should be 4k plus 3, 4k plus 2.
Oo, i-distribute
ay, oh, sorry.
So magamit din mo to siya
Sa ilo ka.
Mas
Buti ay
maayo.
nag-isip ko.
Mas madali.
4k plus 1, so naman ni siya ay
Hindi, 4 plus 4.
4k. Ako lang, buka ko na.
Kunya na. Punta sa distribute sa atin, factorial, para klaro.
Sorry. So you have 4k plus 4 to, so this is 4k plus 4. Tama. So you'll have 4k plus 3.
Plus 2. Ano plus 4 plus 1? Factorial.
Then 4k
4k factorial.
4k factorial.
Daraay na siya.
Okay, factorial.
Okay.
K factorial na akay 4k plus 1. And you have
Okay, plus.
4k plus 3. This is 2,
4.
4k.
k plus 1.
2k plus 1. 4k plus 1. And this is the 2 to the 3. Ano to? 2 to the 3k times 3k.
3 to the k.
3 to the k.
3 to the k. Ano siya? 2 to the
3K.
Times t.
times t. So this is salba na. This is 2 to the ano na siya?
2 to the 3.
2 to the 3. Hindi na ko lang pin. So naka k plus 1.
Okay, na. Plus 3 na. Hindi niya ito.
4k plus 1. I will get 2 to the 3k plus 3. 3k times t. Kanina lang.
3K.
Okay lang, yung magic.
Check ko lang na to, 3 na lang, no?
3 na lang, sir.
3 bantay divisible by 3, anak.
Oo.
May kanin 2 to the 3K plus 1. Ano naman yun, no? At napanin mo diya, ang
Oo.
divisible by 3.
Napag i-multiply yan ni sir, parang by na, kung ano tutulong sa kabuk element, sir, nakalimot ko, sir.
Walang 4K.
Yun ang copy.
Walang 4K plus P siguro pati 2K plus 1.
Ha?
Walang 2 kami dyan.
Really, I think mo, basta sure ko kanis siya, basta.
Divisible by, kailangan divisible by 3.
Oo.
Pero divisible by 3, dapat mo pa, no? Hindi, dapat 3 yun. 3K plus 1. 3 naman lang itong kinanglan. Okay? Ayaw, 3 times
Katulungan mo niya
something.
ko siya, 3 times.
3 times something ato makuha. Para katong 3, i-absorb na
Ito
niya.
yung
Oo.
Kung the rest, dapat natin 3 times something na lang. Di ba? Ang atong kulang, 3 times something na lang.
Kanang ni Kuya sa ubos ba? Times na siya or comma? Anak ti...
Isa-isa lang ka. I-anticipate ba? Eh, wala, hindi pwede.
6K plus...
Oo, times mo, okay.
10K plus...
How do you get 3 times something?
460.
Dapat dihan na talaga nakuha, pero factored form naman po na, oh. Ha? Factored form naman na. So, doon natin tumultiply na, mas mayroon yung factored form na. Pabilit mo lang.
So, hindi lang ito, sir.
Yun sa suspect that it cannot be done by PMI.
Sir, nakakibuhat ng claim, sir. Mga divisible by 3 siya. Nakalimot ko.
Sige lang, ang kalimot mo ikaw, you try to bring that next time, no?
Ah.
In the meantime, class,
Proceed.
diba init pa na sa inyong ulan, una-una, no? You go to page 51, interrupt ka kayo ng 51. Okay. Nakuha ninyo na, row number 9. Ito lang number 9.
Ano yung
Prove
problema?
that-
Hindi ko
Is divisible by 2n.
By
2 to the n.
2 to the n.
Kasi 2N dapat.
Saan ni sir para
Problem set.
problem set?
So ito may
I think that is the problem similar to that. Klaro ba na sa inyong papel? Kung saan na siya ng problem? Okay, will you read it again? Number 9.
Prove that for each n in n plus 1, n plus 2, to the n is divisible by 2n. This is from the Spanish Olympiad 1985.
1985. Okay, bago pa ng tao sa mga natin. Sino ito 1985?
Ikaw, ya?
Uy, Diyos ko, tapos ako.
Okay, magbuwan. Ako na lang.
Ayaw, sir.
Oh, the for each n. Punta kanina siya.
In the natural.
Okay, n plus 2 is divisible by 2 to the n. O possible just ipakita, you go na
Sige, sir.
use now your result, which is easier. Ano na yung result, mas gamitan na ito.
Okay.
So class you start here, you try in next month kung makuha yung principle ng induction. You see how it is proven, using your limited.
Sige, sir.
So erase this part. Load and remove.
Okay, so let's
You go back to the example na.
let's go back to
The same.
the previous example. So find the number of ways to feed
Ipakita sa amin.
Tama.
Using mathematical and induction.
Dito PMI.
Using your katong result na.
Ano to nasa book?
Karong nasa book.
Wala na akong gamit sir. Nakuha mo na ako ni PMI last time na bilhin akong copy.
Adi, try na to na. Dami na yan.
Naaraman sir.
Sige, kung paano makuha. Sige, pakita. May na to?
Ay wala.
Wala sa imong slides?
Wala na sa book. Ay sige,
Dapat sa libro. Isulat lang sa libro. Because if you use them, ay taas mo na siya, no? Just in case makuha yun. But using that result, katong kanina, diretso. Let M be
Akong gamit dito kay Furan 2M. 2M sa 2M na kakuha akong gamit.
bukan itong formula diri para ma-substitute na. Formula is E, L, ano ang masa ito? Ay, tama na ito. Okay. Gagasan is equal to summation. So, ang iyang multi-set,
Even multi-set.
wala naman. Wala. Ayan na.
Okay na lang.
Ayan, ang kaning po yan. Kaning po yan. Ito na po yan.
Money siya ang R.
Aruan. Aruan, ato, okay. Ato, okay. So, meaning to say, ang iyong 4, n ka po is 4n, di ba? So, this is now your, this is now your,
R eyes.
sige, put it. 4n factorial, by the formula, 4n factorial, 4n,
4 factorial. Pero N ka.
ano siya?
So, ang goal namin is mag-divide siya into 2.
Ano siya?
So, this is 4 and this
Sure.
is 24.
Makita lang ni mo na yung ano eh, di ba? Sige.
So, this is 24 and this is 25.
Good. Power supply.
8 times 3 na.
Power supply.
Yeah, 8 times 3.
Ano sir, power?
Ay,
Power supply. Factor.
Power.
3, isa ka 3,
8 times
Isa ka, pila ka 3?
3 times 2 times 2 times 2. 8 times 3.
Okay. Raise to the end. Sige, simplify. Okay, dali lang. Factorial. Ano na?
Simpler siya.
Diba? Yan is simple. Sige, dalawa tayo mong pala.
Sige sir.
Okay, kaya suspect kung hindi pwede.
Easy siya eh.
Diba? Very, very simple.
Okay, mag-continue na ko ha. So, here,
Okay.
so let's consider again this illustration.
Inala to, ayun kalimutan.
Sige sir. You have a set A, kaya siya, A, B, C, D. And the question is, how many 3 combinations of A can be formed when repetition is allowed? So, ano siya? When repetition is allowed, muna yung mga form. So that, ano sila, dala ang repetition. Ano sila? Repetition is allowed. Ano may baby? Basta the rest are the rest of the elements are repetitions. Okay. Observe that given a set A with cardinality of 4, you are about to make 3 combinations out from that set. You'll get how many sets? 20?
4 times 10.
Okay. 20 subsets. So, if you consider M a multiset, kana siya, as N an integer, then you'll have to follow the rule in which, kapag siyang ganina, nagkuha kang 3 combinations out from the 4 objects of that given set. There, a multiset of the form P, kana siya, you have M1 times A1 and so on. Muna na siya ang multi-subset. So that means you have a set. So ito, the set is infinite. You have to group them to make a finite set. So that means katong mga elements, as a representation, you use the infinity as a representation but not a value. So katong infinity times A1, muna na siya to represent that A is written infinite number of times. Muna siya ang representation sa multiset. Now, out from that multiset, you extract another set in which instead of infinity, you make it into a finite number, then that's a multi-subset. Okay, if you notice, it is infinity, di ba? M1, of course, is less than the infinity, siya, and so on. So it's a multi-subset, provided that your MIs as well are integers, positive integers. So, for a non-negative integer R, kani siya, let h to the n, kani siya ang definition. I don't want to read that n sub R, I don't want to read that. Just this symbol, denote the number of R elements multi-subset of M. Okay. So, kana.
Ang R is the sum of MI naman.
Ha?
Ang R nato is sum of MI.
Ang R nato din ha is R elements multi-subset. R elements
Sa taas kay M1 plus M2 plus Mn element.
element multi-subset. So kada siya R elements is R elements. Yeah, it's the sum of MIs. Yes. So okay na ni? So let's consider the example. Okay, you have 3 types of sandwiches. You have chicken, fish, and ham. So a boy wishes to play an order of 6 sandwiches. So assuming that there is no limit in the supply of sandwiches. So if you think of the problem, Suppose wala ko na-discuss ninyo multi-subset or multi-set. If you think of a problem, the key word there, why are we using the word multi-subset or multi-set, is that it's no limit. So we're coming from the word infinity. Nakatong set na contain ng infinity. So that means that since the supply is infinity, we start from the set containing an infinite number of, let's say this is chicken, this is fish, and this is ham. So this is the multi-set of honey, fish, and ham. But that's not the set that we're dealing with. This is the original set, but we're forming a set out from the orders. Dili na siya mako. That's the supply, this is the order. Okay. So, kali siya. Okay, remember, we're coming from the infinite set. So that means it's a multi-set for the unlimited supply. And we're forming a set based on the order. So that means a finite supply. I mean, a finite order. So, kali siya. Dili order na order. Okay, kaya siya. So you have, wala pa akong talk about chicken ha. Ako lang sang ipakita ninyo ang illustration. You have A1 up to AN. Tapos, kani siya. Ako siya i-divide into columns like you have 0, 0, 0, and so on, and so on. To your R1, your R2, your R3, up to Rn. And remember, that's a infinity representation. So, the first row of the table shows the n times of the order. Ito siya. Different orders. Coming from a multi-set. So that means, katong kanina, katong chicken, fish, and ham, mo siya ang order coming from an infinite number of supply. So unlimited supply. So, if you notice, if you have n orders, na ako'y gibuhat nga n minus 1 vertical strokes as division of those orders. That has something to do with them. So, every multi-subset, okay, subset na. So, we're talking about the order, not the supply anymore. Ganina, not the supply, unlimited. Now, here, we're talking about the order. So, every multi-subset, gani siya, of M, where, of course, your Ri is positive, can be represented by a row having Ri zeros within the interval under Ai. So that means, kada Ai na ay mga zeros. Such that, nato sila tanan is counted as R sub 1 number of zeros, R sub 2 number of zeros, and so on. Okay. And suppose each stroke is represented by 1, then every R element multi-subset M corresponds to a unique binary. So, kani, you have, di ba nakay, kato sa 0 tanan, nakay length of R plus N minus 1. So, nakay R ka 0, of course, nakay N minus 1 binary. So, why, N minus 1, 1. Why? Because, di ba, you have N orders, so that means A sub 1 to A sub N.
Where are these strokes?
Yeah, ang ilang strokes kay N minus 1.
Asa nila?
Ano, sir?
Anong ka-divide?
Ano ka
Yung divide.
Yes.
Ang calling the matter.
Wala ako tulas.
So, wala lang,
First and last. Katulas in between.
1, 2, wala lang ang last.
Anong ka-divide?
First.
So,
Divide lang. Sabi ni mga chick.
dapat na-erase na ko na siya, hindi na ko na ma-erase. Wala na ko na-erase eh. So,
Patayan yung itong chicken. Minto to.
yeah, mabalik na dito, Ron.
Illustration.
Okay, so, observe that from the previous report, na ay bijection between the family of R element multi-subsets of them and the family of such binary sequence. So, anak na nila. So, anita, balik na ha. Okay, so take note, your 3 types of sandwiches, the chicken, the fish, and the ham, let's say, sa Malaysia, i-S na ko ni, i-O na ko ni, chicken, fish, ham. Somebody 3 types of sandwiches. A boy wishes to place 6 orders. So, ako din siyang butangan o R1, R2, R3. Okay. Now, out from the, let S be the set of supply for chicken, ham, and fish. The O is the set of orders. Now, ang order daw dato is, order ng 6 sandwiches. So that means, R sub 1 plus R sub 2 plus R sub 3 is equal to 6. Now, coming from the infinite number of chicken, fish, and ham. So, ato i-differentiate that the S is a multiset, the O is a multi-subset. So, dirita. Okay, so let's consider this theorem. Let M be the multiset, of course. So that's the supply. The number of our element multi-subsets of M. So we create an order out from the supply. So this symbol is given by this formula. So remark. Let's consider this. If you have a set X, panacea, with a multi-set, then the number of multi-subsets can siya y1. So that means y1 is less than x1, y2 less than that one, and so on.
You may be equal.
Yeah, they may be equal because pwede man pwede ron tanan ng ang supply. But for all I of x is given by this. Provide for all I. Yes. And the rule that defines f in this case is the same with that of f inverse. Wala na ko siyang digin ha. Ang akong kuhaan nila is kanina. Madali lang kay nani siya.
Go first,
Outline na siya.
Okay, so ano man naman ako ha. For convenience, atin na lang. Your AI, kato mga A1 to AN, I'll write this as 1 to N na lang. Now, consider this multi-set, ganito siya. You have a multi-set, ganito siya, meaning unlimited number of supplies. You suppose A, the family of R multi-subsets of M, and B, the R combinations of ganito. 1, 2, R plus N minus 1. So, you define a mapping here from A to B for each R element multi-subsets of S, ganito siya, of M, where B1 is always greater than or equal to 1, less, and so on.